Hey there, it's been a little while. Well, in the time that's passed since the last time I uploaded a video, there's been a lot of progress on Aux stuff. Now, it's hung around for a fair bit, just kind of stalled, mostly as we were working through some more of the difficult problems. But thankfully, those have been taken care of now. And we've made a whole bunch of progress within the last month, and we're continuing to ramp up. So, super exciting. And that's why I'm making this today, because we need help. And it's about time that you can jump in and start helping with the foundational package set, or I should say foundational packages in the package set. Not even that. It's like we're pretty much at the point of just being able to add stuff, which is super cool. There's still some experimentation to do, and there's still some figuring out of unknowns and working out the right user experience, but I think we're very close. So, what I want to do in this video is take you through what we have in Tidepool, tell you what it is, how it works, and hopefully get you comfortable with it so that if you're interested in packaging things in Nix using Aux Tidepool, you can. And then I'll kind of key you into what things we need packaged next. And so if you're particularly driven to go work on those, you're welcome to join us. So let's go ahead and get started. So first things first, Tidepool is not like production ready yet. It's still in the labs repo. We're still in that iteration phase, but we're getting very close to it being able to graduate, which is, again, so exciting. And so what that means right now is that people shouldn't really depend on this to be stable just yet. We're getting close to that stability guarantee, but we're not quite there yet. And that also means that it's okay to experiment. It's okay to break things. It's okay to try new stuff. And we've done a whole bunch of that. And so if you're interested in working on Tidepool at all, please feel free to try some new stuff. You probably have some great ideas that we haven't had. Now, Tidepool is this package set that is built off of our binary bootstrap. Our binary bootstrap lives in a separate repository called Foundation, Aux Foundation, and that we pulled out of labs a couple of months ago along with our lib implementation, our library. Um, Tidepool uses that set of packages from our binary bootstrap, which is very minimal, and now we're constructing a larger package set, which is much more like Nix packages that you might be used to, this bigger package set with a lot of machinery that does a lot of the work for you. The binary bootstrap stuff that we had was very manual and very tedious, and part of that is the point, is we have very specific needs for that project. But for Tidepool, we can now start building up these common builders and handle packaging more packages and a whole bunch of things. So that's what we're going to be taking a look at today. If you head on over to git.oxalotl.org, or you can click the links in the description of this video, you can find your way to the oxalotl/labs repository, in which you'll see the README that I've been staring at right here, but there's also a folder called Tidepool, and that's where the Tidepool project lives. It's in a folder in this repository. All right, I'm going to open up that README here, and it's still very minimal. I don't think I've touched this in a year. Yeah. So there's not going to be too much help in terms of documentation here. I'm so sorry. There are some ongoing efforts with that, but more documentation will be handled once things are more finalized, right? And that's part of the reason why I'm making this video, to kind of hold us over until then. So how do you think about Tidepool in terms of structure? Well, we have this default.nix, which is the entry point for Tidepool. You might also see a flake. The flake isn't really used at all right now. We'll take a look at it later, maybe, but just worry about this default niche. This is where the magic happens. Okay, so I'm gonna walk you through stuff here, and we're gonna hopefully get comfortable with Tidepool. So do bear with me. I know some of this might be obvious, but it's good for us to pass through. So we're using npins to manage our dependencies. So that pulls in Aux Foundation and Aux Lib. Those are the only two dependencies that we have for Tidepool. There's nothing else. You don't pull in niche packages. There's no other projects. We go ahead and take our lib and foundation, and we have a little helper module here, and we use Aux Lib's, sorry, the helper module is this. We use Aux Lib's module system for our package set. So just like you might be used to configuring NixOS or Nix Darwin or Home Manager using the module set, you can do the same thing with our package set is the idea. So the module system, you can just define options, set configuration, and we do our packaging that way. And it turns out it's quite nice. So we have a little helper module, which just adds our library in and lets you configure it so you can add more stuff to it. And then we also have a little way to inject our binary bootstrap stuff in here. So we just set internal packages foundation to our binary bootstrap. It's really not a thing you need to worry about unless you're working on the very low level parts of this. But this is where our bootstrap comes from. Then the important thing here is that this is a module evaluation. So we run our modules and we just process all the modules in here, and we end up with a config, just like NixOS. There's a little bit of a difference in the interface for Tidepool here. You'll notice there's this little new function, and this is just a convenience helper to let us create a package set and also let consumers of Tidepool easily choose to create their own fresh package set that doesn't actually use any of the packages in Tidepool if they prefer. This could be useful if somebody else wants to, build their own thing. They like the module stuff that we did, but don't like the specific way we package things or what packages are in here. You can do your own thing. Or you can choose to extend the package set if you prefer, just like you can extend any normal module evaluated result. Okay, so what we're going to see a lot of is modules, all right? That's everything in here is done with modules, and that is a little two-sided, right? It's a blessing and a curse because it makes a lot of things really easy to read and really easy to move around. Like the happy path is very nice, but there are some quirks on the implementation side that you need to be aware of if you're going to be working in the implementation side. Okay, so let's take a look at that. So far, all we have is this lib and foundation thing being injected here, an internal packages foundation. And we're going to take a look at source. So source has builders, lib, mirrors, packages. And those are exactly what you might expect. Builders are definitions for how to build things. Lib has some helper functions that are put on our config.lib. And then mirrors is just some configuration that says, hey, there's a GNU mirror over here at this address. Okay, and then packages are our package definitions, right? And our package definitions will use our builders to build. It'll use some library functions as helpers in its definition, and it will probably pull sources by referencing mirror URLs. All right, let's take a look at lib first. You'll see this a fair bit. This is just a module that immediately includes some other modules. It lets us import the lib directory, and we get all the modules inside of it. So this default.nix doesn't really do too much on its own, but we have a couple other things in here that we can actually dig into. Each one of these is a module, and we use lib from config. That's a notable difference. If you are used to NixOS, you might be used to pulling in a lib from here. We do the one from config so that it's configurable, right? So we can set config.lib.platforms, for example. I'm saying from spec is a function, And then that gets added on to lib, and we can even then call other stuff. We have another function down here, expand, which is actually used in our first function. Okay, and so that's how we can extend lib, just by adding attributes, and we have some helper functions. Very nice and easy. There are a couple sections of the library that are built out for Tidepool specifically. We have everything that comes with auxlib that's available in its own repository, but we also extend it with all of the extra modules you see here. So we have some extra options, we have some extra package helpers, we have some extra platform helpers, we have some extra system information helpers, and we also have some extra types that we're using for the module system. Okay, we'll take a look into some of the specifics of those in a bit, but high level, let's keep going here. Mirror is probably the next easiest one. Again, here's just a simple module that just includes some other modules. This one includes GNU, and the GNU mirror is just configured like this. This might get more complex as we go and support multiple mirrors and downloading things. Right now, our fetching capabilities are pretty limited, so these are pretty simple. All right. Then we have builders. So a builder is a definition for how to build a package, okay? And a builder takes in a package and some settings for that builder. So let's take a look at the simplest builder, which is the pass-through builder. This is a builder that asks you to give it a derivation, and it'll just give that to you as its built package. So you're just sort of saying, I already have a built thing, just take this and hand it back to me when you're asked to build the package. Okay, and so a builder is a module itself. So that's why you see the function here. It can take its config. We could do this other ways, right? You can define modules as attribute sets, as functions. You could set a path here, and it'll import that path. But we're defining it here as a function. And that function takes its own module arguments, which are different from the outer stuff, right? This is its own submodule. All right. And so now in here, I can customize this builder as much as I want. So this builder, I told you, we need a derivation. So I say, all right, we have this settings.derivation option that you can set to be a derivation. All right. And then we have to have this build attribute on our config. This is required for all builders. We have to have a build definition, a function that actually takes a package and builds it. And so then we can take a package, and with the settings that have been specified for this builder, we can then actually perform that build. In our case, we're just handing back whatever derivation was set. This is another important piece. Builders will attach additional information to derivations. You might be used to this from Nix packages. If you've worked with just the actual derivation outputs, they'll have meta properties, right? They'll have some extra things that you can access on them. There's this pass-through attribute, PASSTHRU, in Nix packages. Here we call them extras. And so builders will add the package definition itself for easy access. They'll add meta, they'll add this extend, which is important. It's an easy way to extend the original package definition instead of having to go .package.extend. It's just convenience. And so that's the responsibility of a builder, is to build a complete package. And what, you might ask, does that really look like? Is that specified anywhere? it is, we have this artifact type, which asks us if we have a package, if we have meta, if we have extend, if we have extras. So all those things I showed you being attached onto a derivation are required here. This is the bare minimum, is a derivation, and then on top of it, the package definition, meta, extend, extras. All of those are required to be an artifact, which is what's expected from the result of building a package. All right. With that in mind, let's take a look at a more, actually, before we go over to the other builder, let's take a look at something that uses this pass-through builder. So how about we have a package that comes from our binary bootstrap, and we just want to pass that off so that we can use this definition from our package set here as an actual package and get that derivation. Okay, so we're taking a derivation that already existed somewhere else in some other project, and we're just going to bring it into Tidepool. Okay, the way that we do that is we specify a new package. Sorry, jumping ahead. We specify a new package. So we say config.packages, and then you pick a namespace. In that namespace, you then go ahead and pick a package name, and you have a couple options that you can set. So we have the ability to assign a stable version if we want, the ability to assign a latest version if we want, and then all of your versions for packages live in here. Each one of these versions is a submodule that defines how to build that version of the package. And you'll notice we've decided to separate those out into different files for convenience. So now let's go ahead and take a look at this package, which just pulls in the binary bootstrap bash. So this is the actual package definition here for this version of the package. So for that version of the package, we have this config, and we say the meta options. We set the platform support information. This is telling Tidepool what platforms this package can be built for. And then we have some builder information. So here we're taking the builders, which comes from global, referring to the outer module config, the bigger thing out here. So this config right here, since we're in a submodule here, we need to get it somehow. So we get global, and that is Tidepool itself. We grab our builders, and we can say builders.foundation.passthrough, which is the builder we were looking at. And what we're going to do is we're going to extend that builder with a new bit of configuration. And so remember that settings.derivation option that I mentioned before we took a look at? Well, we're setting it here. So we're extending the builder with custom settings just for this one use case. All right, and so that derivation gets set to stage 2 bash. So now we have a full package definition which will be capable of building this stage 2 bash package, because it's just going to hand us our derivation that we already had. So very simple, very easy. But let's go ahead and look at how we can actually build this. So I'm going to be using the nix command, not nix build, but rather nix space build. And so if you don't have that available, you'll want to look up how to turn that on. But what we're going to do here is from the labs directory, we're just going to say -f tidepool, and then we can add a -l if we're wanting to see a bunch of logs. But the thing that we care about is we're going to say packages.foundation. And actually, since we're going to be specifying some stuff, let's see, you know what? Let's just build the latest one. Remember we had stable latest and versions. So we're just going to specify packages.foundation.bash.latest. And then we're going to specify what system we're going to build for. Okay, and right now, this is not the expected end user experience. This is just an in-between where we don't have the fancy end user experience just yet, but you can access things directly right now to actually interact with them. So all of the built versions of the package exist on the package at this .packages attribute. And we're going to say we want the build system to be x86 64 Linux. We want the host system to be x86 64 Linux. And then we want the target system to be x86 64 Linux. So this maps to, I want to run on x86, or rather, sorry, let me start over there. I want to build this package on x86. That package is then going to run on x86. And if it were a compiler or something, you would emit code, it would emit binary stuff for x86 as well. Okay, and then to get the actual derivation, we say .package. There we go. I've already built this, so it was pretty quick. It might take longer for you. You might have to build the whole everything, but we should see this result directory, and we have bin bash. Cool. So that's useful for pulling a derivation from somewhere else, which, you know, maybe from Nix packages, you're like, okay, well, I can just use Nix packages stuff. Why wouldn't I just do that then? Well, we're trying not to. So we have some more advanced things now to look at. There is another builder that is called the basic builder, because still it too is quite plain. We haven't gotten super complicated with a bunch of build systems and things yet. Things are still pretty manual. But this builder does have some more things going on. You'll notice it's a little bit longer, but thankfully it's actually not that hard to understand for us. And I think in order to understand it best, I want to just show you what a package definition looks like. Let's see. Okay, that's close enough. So we saw our package definition before just had this config and had meta going on. So that's the same. We have some platform information, and interestingly, we have some more platform information for this package. It actually supports multiple platforms. It supports building on i686 Linux or running on x86 64 Linux. Pretty cool. And then it also supports building on x86 64 Linux for running on any Linux machine. And this just means set target to be the same value as whatever host gets set to. Okay, and then instead of the pass-through builder, we have the basic builder. We don't need to extend it to add any configuration. It just works right out of the box. Like, that's it. So then for this package, we're actually going to be fetching some source code and running some commands to build it. We're going to have some dependencies, so we need to do some more things than we had in our pass-through builder. So what we're going to do here is we'll set source to fetching the source of this program. So we're just going to get some source code. Okay, and then we have deps. So deps are our dependencies. So all of the dependencies for your package that you might be familiar with in Nix packages, like build inputs or native build inputs, well, those come under the deps attribute in your config. So there are a couple different places that you can put them in deps. You can have deps build build, build host, build target. You can have host host, host target, and you can have target target. What the heck does that all mean? Well, what it means is we have this build, host, and target stuff, okay? And build is the machine that builds the program, okay? Host, the machine that runs the program. And target, the machine which gets binaries generated, or rather gets code generated for when the program is run. So this last one sounds super weird, and it's a little weird to describe, and that's because it only applies to compilers, and even then it only applies to specific compilers. So build, really easy to understand. It's the system that you're probably running Nix on. You're probably building on that machine. And if you're not building on that machine, then you know where you're building, because you're doing some fancy distributed building stuff. The host is where that program that gets built will eventually run. So it might be that you're building on one machine to use it on a different machine. And that second machine is the host. Sometimes, and fairly often, these two are the same. You're building and then using the package, and that's fine. Target, like I mentioned, is if you have a compiler that you're building, well, that compiler is going to spit out stuff for another machine after it's run. So you have the place where it's built, the place where your compiler runs, and then the machine that your compiler spits stuff out for to then use later. So that's what the target stuff is. So build, we have the ability to set builds. What is that going on here? Well, we have a system that we're specified for our platform. So we have config.platform, and we have the build, and so we have, for example, x86-64 Linux. We also have a host and a target system. So this gets configured by the user when they build your package. So remember when we over here had .x86 a couple of times? We're saying I want this build, this host, and these target systems. And that'll give us the right package. So it'll be configured exactly like this. Okay, so with that in mind, how you specify your dependencies will change how your dependencies get their platform information. So build means I want the platform information for these dependencies to be set to build is the same as my build, host is my build, and target is my build. And so for us, I know the naming can be a little confusing, but this is x86-64 Linux, right? For us, if we're building on x86-64 Linux, then I want all three of these to be the same for these dependencies, okay? So the point is deps.build.build means all of the build, host, and target stuff for the dependencies in there will all be set to the same thing, and it'll be the build machine. So it's all stuff that is intended to run on, it's intended to be built on and run on and generate code for the machine that we're building with, okay? So that's build.build. We also have build host, which is slightly different. So let's say we were targeting a different host here. So host B or something, or i686 Linux or something else, maybe AArch64. And so if the host for our package, stay with me here because I know this can be confusing. If the host for our package was AArch64 Linux, so we have build, host, target. If the host for our package was AArch64, then what we end up with here is, well, we're building on our build, and then we're using build host for dependencies for these two. So we have build host, and that's how it gets propagated. So hopefully you're realizing that it's build is always what we're building on, and then these two here just map directly to this nested selection path where we say it's build and build, or it's build and host, and here it's host and host, right? So We have AR64 Linux, for example. And so that's something that is built here, but is intended to be used on the other system entirely. Okay, and we also have target. And you can do stuff there as well. So thanks for suffering through that with me. I know it's complicated, or if it all made sense, then I'm sorry to bore you. The next little bit is how we specify our dependencies. Please ignore this little dance that we're doing here just for our bootstrapping stuff. It's because we didn't have cross-compiled things. You won't ever have to do this, but the way that we specify dependencies here is we actually just assign them. We say, yeah, I want GNU make in my packages. You'll notice it's an attribute set of dependencies, not a list. So Nix packages specifies build inputs and things using a list, whereas we use an attribute set. And the reasoning for that is that you can actually do proper overrides. You can nullify things if you want to just completely void a dependency entirely. It's much nicer. So we say, yep, I want GNU make. You can name it whatever you want here. This is entirely arbitrary, but then we assign the value is the package definition that we want. It's not the derivation, it's the package definition. And that whole definition gets pulled on over. So I'm going to say, yeah, I want packages, foundation, GNU make, and I'm actually even going to pick a specific version. I don't have to type this. So if I were to come in here and say this would be the same as saying, give me the latest one. But we're locking these versions on purpose here. So I'm just saying, yep, give me that specific one. And that's it. That's actually all you need to do to add a dependency. All right. So with our dependencies declared, how do we actually build the package? Well, similar to Nix packages, we have phases. Now, they do belong in their own attribute set, and they are slightly more complex than they actually look right now. So what you're seeing here is this simplest version, but you can add custom phases in here. So like my phase, and say, let's see if I remember how to do that. Let's get an example for you. Say between unpack and configure, we're gonna do some stuff. And you'll notice this is actually a graph. So this is a DAG and a directed acyclic graph. And all that means is that they're ordered. And these named ones that were already here are just written as strings because they already have an order declared in the builder, so they're well known. But you can add your own with this sort of syntax by saying where you want your DAG entry to go. So there's the ability to put it between stuff, or you can just say before or after, and you'll be good to go. So we can write our build scripts pretty similarly to Nix packages. We have, maybe we're unpacking the source, we're running configure, we're building, and then we're installing. And that looks pretty similar, doesn't it, to Nix packages stuff, albeit more manual because we don't have some of the fancier builders just yet, but hopefully you'll be contributing some of that. All right, so now that we've seen how we define a package, let's look at how that builder actually works. So the builder over here might seem a little intimidating, but we're going to step through it in the different chunks that make it up. So we have this build function that takes our package definition. So it'll take this whole package definition here that we're seeing on the left side. And we have some platform information. We're building for a particular system. or building on a particular system, I should say, we go ahead and collect all of the dependencies for that package. So this is a helper that will grab all the dependencies defined in deps, and it'll also grab any propagated dependencies. So anything that is intended to bubble up as a dependency of a dependency, we'll get that too. All right. We then are going to create this thing called context. And we'll take a look at this a little bit later, but just know that we're going to use our package and the information from our dependencies to make some kind of context. Then we're going to create some package hooks, which again, we'll look at in a little bit, but if you're familiar with Nix packages, it's very similar. It's just some extra phases and stuff that we'll run. And then we go ahead and get our phases, and we do a little bit of a dance to extend our phases, basically, of like, just give me all of the hooks for those phases. Okay, and so now that we have all of our build phases and all the hooks together, every single piece, we can go ahead and apply some defaults. So that's the patch, unpack, configure, build, install stuff that I was talking about. So we have a couple well-known entries here, and that's just because it's supported in this builder specifically. Other builders might not know about it. And we're just using this helper to apply some defaults. Wonderful. And then now we sort that. So this graph gets sorted. We now have an ordered set of build steps. So we go ahead and turn that into a string. And then we create our built package by just calling builtins.derivation. Yes, we just now get to use the raw Nix built-in for derivation. Packages can specify an environment, and so we're adding that onto the derivation because that lets us expose things to the environment. And then we have some required information. We have the name of the package, we have the system of the package. We're passing that script as well, right? The actual build script here. And then we're also making sure that we pass that as a file. So this is a Nix specific thing where if you call builtins.derivation, you can give it arguments, right? So I could say script is echo 5 or whatever. And if you say pass as file and tell it that attribute name should be passed as a file, instead what it'll do is it'll take the content of that attribute value that you set, in our case script, it will write it to a file, and then it will set the script environment variable to the path to that file so that we can then read it back and use it. All right, we're also setting the shell environment variable, we're setting the path environment variable, just globbing up all of the dependencies bin folders. We're setting the builder for Nix to use. So this one's required for Nix, and just us saying, hey, you're going to execute bash. I glossed over executable here, but again, ignore the dance we're doing because of bootstrapping and cross compilation. But functionally, all we're doing here is we're saying, give me bash /bin/bash. That's it. All right. And then we have the actual thing that kicks off the build here, which is a little bash script that we run. And it just sets up some configurations so that we can use all the cores of the machine for building stuff. And then it runs our script that we had set. The result here then gets added onto it with a couple of things, right? We looked at before, in order to have a valid artifact, you need the package added onto it, you need meta, extend, and extras. And so we do that. And there's a little bit of validation checking on the graph. And that's it. We end up with our derivation. So now that we have that, we can start taking a look at some more advanced use cases of things. Or at least that's what I would say if we had more advanced use cases of things, because we're just at the point now of wanting to add those. The only things that we haven't really talked about are context and hooks. And I feel like those are the things that will be enabling us to make those higher complexity package builds and dependency chains actually work. So let's take a look at this. We have GCC packaged here. And GCC needs some extra information whenever it's actually used as a dependency. So if I build something with GCC, we need GCC to be configured with the right flags. We need to call GCC correctly each time, and we need to link certain things. So what we end up doing here is setting hooks. So what is a hook? I glossed over it saying, well, it's just a build phase because yes, so hooks here, any package can declare hooks, and these hooks are not used in this package's build. Instead, these are hooks where if I use this package as a dependency, these hooks get applied. So these hooks are only applied to the thing that is depending on this package that has these hooks. All right. So it's a way for us to expose some extra phases for any consumer of these packages. All right. So what we do is we say, I am going to make some hooks. That takes in the context that we may or may not use right now, but we'll take a look at what context is. So we take in context, and then we give some phases. And you'll notice this is actually the exact same as our phases down here. In fact, we specify it the same way that I showed you before by saying I have a DAG entry. It's going to happen after unpack, before configure, and here's the code that it's going to run. And that's it. That's what it does. Exactly what you're seeing here ends up being merged directly into the phases, remember, not of this package, but of anything that depends on it, and gets executed. So anything that depends on GCC will automatically have all of this run before its configure step. Nice and easy. So now you don't have to worry about configuring CC for target, or all that. And we set up some flags to use, make it nice and easy. Okay, so that's hooks, but what is this context thing that's like floating around? It's kind of magic right now. Well, context is actually really cool. Let's say for a moment, I have this package A, all right? Package A depends on some package B. Package B has a context. In fact, it has context and environment stuff. But we're going to look at context here. So we have A depends on B, and B has this context thing. So context lets you specify additional information which is exposed to all of the packages that depend on or that are being built. Sorry, let me try that again. So we have this context, okay, and it's used in our hooks. This context is all of our dependencies, contexts. They specify some additional information that they want to expose. All of those get merged together, and that becomes the context that we use for our hooks. So it's a way for packages to expose extra information for when they're used, and that information can then be referenced in hooks. So we can use it to build steps. For example, in this simple version, B can specify, oh, here's some C flags that you need to be setting when you use me as a dependency. And this context can be automatically used, and GCC can be configured automatically to provide these flags. We don't do that currently, but that's the plan. And you can wire that up today. So context is some values that our package provides, it exposes. That gets scooped up by a builder, which takes the context of all of the packages and merges them. And then hooks can reference that context. All right, that's really useful that it takes all of the context from all the dependencies and merges them, because that means our GCC, for example, right here, can add GCC flags based on context now. All right, so that's context. And you might be wondering next, how do you add stuff to context? Like, you're saying that you can expose things in it. Can I just put whatever here? Almost, because this is a module, right? And so we have to specify the options. So let me go over here and show you how we specify some options. We get to say package.context.options and actually just create options. Notice that we do this in config. It seems a little bit quirky at first. Trust me, it's fine. And we come in here and create our option. We do it just like normal in our module. Nothing special here. And so we say, yep, C flags is a list of strings. It's just a default empty list. And then we're done. So then we can use foundation C flags here. If I wanted whatever to be used here, say lib.options create. There we go. Forgive the very hasty autocomplete, but trying to get the point across quickly. So we can just say create our option, and it can be whatever we want. And then that can be used in context in our packages. You can assign that. So that's the current state of things with Tidepool, where we have our packages, our builders, our lib, the mirrors. The specifics of the implementation would take a while to really go through everything, but I don't think we really need to dig into much more than we use in the basic builder here, where we have a couple of foundational helpers that are really important for collecting dependencies, for creating a context from those dependencies for a package, to creating hooks using that context. And then, right, we get our phases and merge our phases and hooks. We go ahead and default those, we sort, we get our build script, and then we actually make our derivation. So I think for the most part, all of these things will be consistent across any new builders that we create. So what is it that we're trying to do next? Well, right now we have GCC and glibc. Just the packages that you see here in Foundation, which I've been told is confusingly named, I'm so sorry. But in packages.foundation, we have just kind of the base set of packages, which is all the stuff from our binary bootstrap, but then recompiled by itself and added cross-compilation, basically. And so that's why I named it that. So anyway, we just have these right now, and you'll see it's a pretty small list, and it's cool that we have all this working. But now, what I would really like is to have licks working. So what we need now is new packages. We need more packages, and in order to build all of those, we're going to need new builders. Things that know how to build CMake stuff, things that know how to build autoconf stuff automatically, things that know how to build different kinds of projects out of the box with less configuration would be great. And so we need all of these packages packaged. We need builders to support everything. And from there, we kind of run free. We don't need Rust platform. or Rust C. Oh my goodness, we're not bootstrapping that yet. Unless you want to do that. If you want to bootstrap Rust in Tidepool, be my guest. So that's where we're at right now and where we're looking to go. I would love to see anything that you want to experiment with Tidepool. Like if you want to add new packages, new builders, simplify code that's already here, improve the cross compilation stuff that we already have, I would love it. Seriously. All the help that we can get, I'll take it. So in terms of actually knowing what's going on in the package set so far, I think we're hopefully feeling a little more confident. We haven't dug into a lot of the implementation specifics here, but while there might be a lot of code, the majority of it, aside from systems, which is just very, 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 very long, you don't have to worry about this, honestly. The majority of the code is fairly reasonable to go through. You should be able to understand what's happening if you wanted to read through things. And yeah, if you feel like working on stuff, you can iterate adding packages in core here and, building your package, right, as we showed over here. Ta-da. If we want to build GCC. Yay, I have GCC. I just built it, so it's, again, instant. Wonderful. The last thing I'll mention, just as kind of wrapping things up, the flake here just exposes the raw exports here, so that's not valid flake schema. Tidepool, yeah, it's going to be very confused about everything, so don't worry about it. It's not worth it. And flakes are probably not the future anyway. So, yeah, if you have any questions, feel free to jump on the Aux matrix instance. You can find all the information about contributing on the forum and the chat and all that stuff over at oxalotl.org. You'd find, again, links in the description. So if you have any questions, feel free to come ask. I would love to see you folks toying around with Tidepool. All right. Well, have a wonderful rest of your day, and if you decide to play around, I hope that you have fun.